Differential and integral operation 6. Let a vector field V be given by x e x hat plus y e y hat. Use Stokes' theorem to evaluate the line integral closed path integral dr dot b, where the the closed path, is the unit circle in the xy plane centered at 0, 0. This is in part A. In part B, C is a unit circle centered at 1, 0. And in part C, evaluate the two integrals above by actually performing the line integrals themselves. We are given a vector V, which is x e x hat plus y e y hat. And Stokes' theorem tells us that the surface integral d sigma dot curl of V is the closed contour integral C, where the contour is the one that is at the boundary of the surface, dr dot b. So that's Stokes' theorem. Now let's calculate curl of V. Curl V is the determinant. First row is ex hat, ey hat, ez hat. Second row is del x, del y, del z. And then we have x component x, y component y, z component is 0. Now, if I perform this determinant, for the x component, you can see will be plus, minus, plus. For the x component, I have del y 0, 0, del z y is 0, so that term is 0. For the y component, del x 0 is 0, del z x is 0, so that term is 0. For the z component, x derivative of y is 0, minus y derivative of x is 0. This is actually 0. All right, so the Stokes' theorem tells me that the surface integral d sigma dot product curl V is the contour integral C dr dot B. Now the given contour is a closed contour, therefore this is 0 by Stokes' theorem. This is our conclusion. In part B, we have another closed path that is also 0 for the same reason. Okay, now we're going to actually perform the line integral. First, we're going to do C, the unit circle, which is centered at 0, 0. And if we use the polar coordinates here, dr is r d theta hat, and our vector V is actually the r vector, x e x hat plus y e y hat. This is our r in r hat direction. So the given vector V is actually the position vector r. Okay, for a unit circle, obviously the magnitude of r is equal to 1. And the small displacement vector dr is r d theta hat And since r is equal to 1, this is d theta, theta hat. So if I look at dr dot product with vector v, it is d theta, theta hat dot product with r hat. So what is theta hat dot product with r hat? Now you can see that this is my r hat unit vector, and here I have the theta hat unit vector, and they are perpendicular to each other. The angle is 90 degrees, so that dot product is 0. So we can conclude that the closed contour path integral dr dot product with v must be equal to 0 for the circle centered at 0, 0. So the contour being the circle centered at 0, 0. Now, as for the second path, we have C, now unit circle, which is centered at 1, 0. And now our position vector r is x minus 1 ex hat plus y ey hat when it is centered at 1, 0, which is v vector minus ex hat. So that's the position vector. dr, the displacement vector, is again r d theta, theta hat, where r is 1, so it's d theta, d theta hat. And v vector is r plus ex hat, which is, because r magnitude is 1, r hat plus ex hat, we were given, it's a unit circle, r equals 1. Now if I look at dr dot product with v, it is d theta, theta hat dot product with vector v, r hat plus ex hat. This is, because r hat dot theta hat is 1, d theta, theta hat dot product with ex hat. Now, from the figure, we can figure out the x component of theta hat. So this is our r hat vector. Here's the angle theta, and if I follow this line, it's also the same angle here, theta. These are parallel to each other, so it's the same line following this path. And this is a 90-degree angle, and this is a 90-degree angle, so this is 90 minus theta. So theta hat makes a 90 minus theta angle with respect to the x-axis, so it is cosine 90 minus theta, which is sine theta in ex hat direction. So I can write theta hat is equal to sine theta in ex hat direction, and its y component is with sine of 90 minus theta with cosine theta in minus y hat direction. So this is minus cosine theta ey hat. So I see that theta hat dot ex hat is equal to sine theta. Therefore, the closed path integral, the theta goes from 0 to 2 pi, dr dot product with v is the integral from 0 to 2 pi sine theta d theta. Now, the derivative of cosine is minus sine, so it's going to be minus cosine theta from 0 to 2 pi. Cosine 2 pi and cosine 0 are equal to each other. So we find that the closed contour integral dr dot v must be 0. So we can see this explicitly by performing the actual line integration. Okay, so in this problem, we have a vector field V given by x hat plus y hat. Using the Stokes theorem, we want to evaluate the closed path integral dr dot V on the path where, which is a unit circle centered at 0, 0 or 1, 0. Now, using Stokes' theorem, if I check the curl of vector v, I find that it is 0, and Stokes' theorem tells me the surface integral, the sigma dot curl v, is the closed path integral over the contour C that is at the boundary of the surface, dr dot v. So, since the curl is 0, this integral is 0 for part A and B. And part C says evaluate explicitly these two line integrals to show that that's the case. Now for a unit circle r is equal to 1, the displacement vector, small displacement vector, is r d theta in theta hat direction. And we have the r vector x hat plus y hat is r in r hat direction, but r is equal to 1. So the given v vector is actually the r vector, where r is equal to 1 with this. So we have dr vector r d theta theta hat dr dot v basically gives us r d theta theta hat dot product with r in r hat direction, but theta hat dot r hat is equal to 0 because they're perpendicular to each other. This contour integral is 0. On the other hand, if the circle is centered at 1, 0, for the dr dot v here, we have to look at the position vector, which is x minus 1 ex hat plus y hat. This is telling us where r is defined because at x equals 1, y equals 0, we have the new center. This is vector v minus ex hat. We can see that from this expression. So v is r plus ex hat. So r is r hat, but r is equal to 1 on this unit circle. So this is r hat plus ex hat. And our dr vector is r d theta theta hat, which is d theta theta hat, because r is 1 unit circle. So dr dot v gives us d theta theta hat dot product with r hat plus ex hat. Theta hat dot r hat is 0. Theta hat dot ex hat is the x component of theta hat. X component of theta hat can be found from this geometry here. It is theta hat multiplied with cosine 90 minus theta, which is sine theta. So this is in sine theta ex hat and minus cosine theta ey hat. Its magnitude is square root of sine square plus cosine square, which is 1. So theta hat dot ex hat is sine theta. Sine theta integral over the angle 0 to 2 pi for the complete contour here is basically 0 because it's cosine is a periodic function with period 2 pi. So we find that the closed path integral dr dot v should indeed be 0.